So just give a brief introduction about the program, Nigerian Energy Support Program, and what we're currently doing. So NESP for short, that's a Nigerian Energy Support Program, is a program under GIZ, commissioned by the European Union and as well the Federal Ministry of Economic Cooperation and Development. So this is where the funding comes from, about 30%. 70% from the EU and 30% from the German government. It's implemented by GIZ, that's the program NESP, and it's in collaboration with the Federal Ministry of Power. This entire program actually started from way back in 2013. That was NESP1, which ran for about 4 years through to 2017. And then the second phase of the program was initiated since 2017, and it's been ongoing till now, and it should run till around May 2023. Our approach is basically to provide advisory services to the Nigerian government with regards to energy policy and management. And the objective is to promote investment in the domestic market for renewable energy, energy efficiency, and rural electrification. Next slide, please. Yeah, so under the Nigeria SE4ALL initiative, we were able to develop this platform or the website, which is now online, the Nigerian SE4ALL.gov.ng. This is sort of a platform which houses all of the projects and that's been implemented under the program. Various types of data for electrification planning, which has been collected during these phases of these projects, have all been uploaded onto this platform, and it's easily accessible to download all this data. So you have all OpenStreetMap building data that we collect during these mapathons as well, is being integrated into this Nigerian SE4ALL web map. You can click the link or you can just copy this out. Feel free to visit the website or the platform. I'm sure you'll find a lot of interesting data sets there that could be useful to any of you guys in school or anyone trying to do some kind of analysis or run some projects of their own. Next slide, please. Yeah, so this is now covering some basics of GIS. What is GIS? We all know this is short for Geographic Information Systems. And basically, it's a system used to capture, store, analyze, and manipulate geographic or spatial data to understand or to carry out analysis and understand results for decision making, or to help guide in decision making, basically. So these are just this is just an example of geometry types. These are examples of geometry types that are used under geographic information systems. So we have the points, we have lines, we have polygons, and we have multi-polygons. So what's the idea behind geometry types? It's basically ways that are used to represent physical features on the Earth's surface. So the idea here is, this is just a general overview, and we will go in depth into the main basics of GIS in the further slides, but this is just an overview for people who don't really have much understanding as to what geographic information systems is. So it's this map here to the right just shows an example of what you can achieve with GIS, how you can represent information and data using these types of geometry. That's the point, line, polygon, and multi-polygon. As you can see here, this map showing the example of the Russian invasion of Ukraine. You see how with the use of lines, points, and polygons, you're able to tell a story, and it's easy for someone to see the map and understand what's currently going on within Ukraine. And just get basic understanding of what's happening, and be able to make some kind of analysis just mainly by looking at the map. Another similar example is this one is quite interesting because you can see it's a GIF and it's polygons that are appearing here. It's just the WHO Ebola situation reports from, I know we all heard about the Ebola crisis that happened way back in 2014. So this is just a map kind of, yeah, this is just a map kind of representing different data sets that were collected during that time. And it's also done basically using these geometry types that I already spoke about: points, lines, polygon, and multi-polygon. So we'll definitely go in depth to understanding basics of GIS as well in further slides. Next, please. All right, so I think that's the end of the introduction session about us, and as well as basics of GIS. Right now, we're going to the open talk, and the topic for discussion today, like Wanola mentioned, is how to collect GIS data on grid availability using mobile mapping technology. And for this session of the Mapathon, we're going to have NESP, and that's the Nigerian Energy Support Programme, alongside Red Fox, which is a company who is a consulting company who is in charge of doing the actual field data collection. They will be sharing with us their experience on the field, as well as other interesting points that we'll be discussing in the next slides. I think at this point, I'll hand it over back to Wanola.
Yeah, thank you, Philip. Thank you so much for the intro section and for that brief intro to GIS. I think we can now move ahead to the next session. So, like Philip said, for this session, we have NESP and Red Fox who would be telling us about um, the mobile mapping technology and how to use that technology to gather data on grid availability. So this will be the agenda for the talk. So we're going to first talk about, what is the mobile mapping system, and then we'll learn the type of GIS data that are captured and how are they captured and extracted, and analyze the tools, the software that are used for this purpose. And then there's a brief video just to that captures what would be taught in these two topics. And then we have Red Fox who would come and we have Sylvester from Red Fox who would come and tell us about their experiences on the field, and answer some of the questions that we might have in our heart. And then we have Tokwe from NESP, who is also going to talk to us about the application of the technology, and then the relationship between grid tracking and the remote mapping. So the remote mapping is what we do when we gather together to do this mapathon. So we're going to be learning how that also helps with the grid tracking and the project as a whole. So hi Chukudi, are you ready?
Yes. Hi
Okay.
everyone, I'm ready. Okay, so just to pick up from where Philip left us, we're talking about the basis of GIS, and he also mentioned how we can collect data. So the mobile mapping system is a process of collecting geospatial data from a vehicle mounted camera that has several sensors that can, for instance, can have LiDAR and also other optical sensors. What this device does is it takes snapshots as the car is driven past on the road. It takes snapshots of the physical phenomenon around, and then these snapshots that are taken can then be further analyzed um, in the office to extract data. And then this, of course, these data are extracted either as points, lines, or polygon, just as Philip mentioned. So the mobile mapper has several components. One of these components is it has a GPS receiver. Now, what that component helps us to do is so that whatever is captured can be eventually georeferenced. I will talk more about that later. It also has a laser scanner, it has a camera, and then Wi-Fi enabled computers, and then also a storage in the in the device. The this mobile mapping system, when it takes these snapshots, it takes them in a very high density rich images. It does also save time for data capture. It also saves budget, and then because it saves budget, more work can be done with little time. Next slide, please. Okay, so we have a closer look at the mobile mapper. For the project that Red Fox will talk about later, we are using Trimble MX7. As you can see on the slide, it has about 5 cameras, one in front, where this yellow arrow is pointing, one in front, one just at the back, and then 2 by the sides, and one that is facing up. A very good illustration of what this mobile mapping system can do is, if you know your Google map, if you switch to Google Street Maps, you will notice that you can have a 360 spherical camera view. So this is the device that makes that kind of view possible. Like I mentioned earlier, it has an internal storage of 2 gigs. So as the mapping is going on, it is being stored, and then it's also advisable that the surveyors or mappers have external hard drives so that they can also transfer data where the 2 terabytes may not be enough. So the process of data collection involves data capture, data processing, and then data extraction. Next slide, please. So what we do when we're about to go on a mission, it's like every survey or any mission that is done, there's always need for reconnaissance. In other words, to understand the environment where this data is going to be collected. And then the process of data collection happens with the car, when the car is driven on the road around the vicinity of the place where the data is to be collected. So to data processing that I mentioned earlier, we use a software called PostPack to process this data set. What PostPack does for us is it helps us georeference it helps us to georeference the data that we get through our mobile mapper. And then the output of PostPack is then imputed into a software we call Trimble Business Center. What this Trimble Business Center does for us is it now produces a panoramic image, a georeferenced panoramic image of the route or the route that we have driven past. And then this output is then imputed into a software we call Orbit 3D feature extraction. It is in this Orbit 3D feature extraction software that we then digitize the features of interest. Since our topic is electrification, so we digitize things like poles, the lines, the transmission lines, for example, 33 kVA, 11 kVA. And so depending on what the project is about, that's what the digitizer extracts with the aid of the Orbit 3D feature extraction. I think that's it. I think I'll hand it over back to you, Omonola.
Okay. Yeah. Thank you so much, Chukudi, for that. So if Chukudi just gave us like a brief introduction into the mobile mapping system and the type of device that we've been using to collect the project and how the data capture, process, and extraction works. So I'm just going to play a short video just to explain, just to give you like a brief oversight of everything that he has been saying. Hi, Joseph. You have your hand raised up.
Hello, sorry, that was a mistake, but the audio, I didn't get the audio anyway.
Okay,
Wow.
just to quickly
For the video.
respond to that, we'll place the link to the video. The video is on YouTube, so you have access to it. We'll send the link on the chat now.
Yeah, okay.
All right,
Thank you so
thanks.
much for that.
Okay, thank you, Tokwe, for sending that. Yeah. So just check your
Yeah.
chat, you'll see the link and then you can watch it.
Yeah, okay. Yeah, thank you so much, Ukudi, for that. And thank you, Joseph, also for pointing that out. So now we are going to hand it over to Sylvester from Red Fox. Like Philip said, they've been the one. Oh, sorry about that. Yeah, they've been the one. So Red Fox is a consulting organization. They've been the one going on the field to collect the data. And so we have Sylvester from Red Fox to share with us some more insights from the data gathering on the field and just to learn from what they've been able to do from by using the device. Hi, Sylvester.
Hi, everyone.
Hi, good afternoon.
Good afternoon.
Thank you for
So,
joining the call.
thanks for inviting me to the call. So, quickly, I'm going to discuss on the best practice and standard operating procedure in the field using MS7 device. As we all know, as you could have earlier said, MS7 travel device is a
Hi, Sylvester. We lost your audio. Is it only me?
So my discussion is going to be based on these few bullet points displayed on the screen: security permit, community relation, site visit planning, instrument setup, and the challenges faced while collecting data. Because of the sensitivity, hello, can you hear me?
Yes, we can hear you, Sylvester. We can hear you.
Okay. Because
Yes,
of the
we can hear you.
sensitivity of this, because of the sensitivity of this device and the cause effect involved, combined with the challenge we have in Nigeria, we have to solve for security personnel that will assist us while collecting data. So we have applied to the Nigerian Police Force to give us a permit of 2 police personnel that will assist us to during the course of data collections. And having done that, we liaise with the community involved in the area that is involved for those data collections so that they will be aware of what we are doing, because as you can see, the equipment itself is so conspicuous, it can be sighted anywhere you are, at least 50 to 100 meters away. So we discuss with the chief, the village head, and the youth around, then tell them what we are coming to do. Then they give us permit, they will proceed to the site. While carrying out site visit preparation, we have to take into consideration the available motorable roads that we are going to drive the MS device, because it has to be mounted on a moving platform. And as it is, we need a motorable road to use it. Then we also take into consideration the visible utility that we are interested in capturing, like the power line transmission. And as you all know, there are some that are not actually visible to the sensor coverage, because some of them are very far away from the road. They will take notice of that. They will also take notice of the areas along the road that are not too good, then areas that are very good. Then we also take note of the congested area, like built up area, where we need to drive very slow, and areas that are not built up that we can drive very fast. Then we take note of area along the road where we have transformers and area that are no transformer. Then we make preparation on how we are going to start data collection based on the available road network that we are going to use for data collection. Having done that, then we are fully set for data capture. Then, as Chukwudi has earlier explained, the first thing is to mount the device on the vehicle, then set up the system itself, both the GAMS and the power pack. Then after setting up, then we initialize the system, which sometimes do take a bit some time for the system to get initialized. So after initialization, you will see that there will be a green pop-up icon that will come up on the tablet, which indicates that the system is good to start data collection. Then we will start to drive around the route under investigation. And in the process of driving, you have to take notice of the speed of the car so that you'll be able to set the trigger frame in accordance with the speed of the car. And this can be done while driving the car. You don't necessarily need to stop. While the data is captured, you can change in accordance to the speed. Take it for example, if you are driving at 100 km/m, you have to set the trigger setting at 100 km/h. If you are at 20 km/h, you set the trigger setting at 20 km/h. And how do you do this? If you look at the speedometer of the car, some cars, you will see they write it there 100 km/h. So now, if you are driving at 20 km/h, then you have 60 minutes in 1 hour and 60 seconds in 1 minute. And if you look at the trigger setting is set in seconds. So if you have 80, what you do now is to divide that 80 km/h by 120. So if you divide, you'll be having about 0.6 thereabout. Then it indicates that the trigger set is going to be on 0.6 or 0.5. Then if it's 20 km/h, you are going to do the same thing. Divide that 20 by 120 seconds, then you get like 0.01 or 0.1. So in that case, you'll be able to gather a considerable and convenient data set that will not stress you while processing the data. So now we'll quickly discuss on the challenges faced while carrying out data collection. The first challenge was what I just finished discussing. Initially, we did not quickly realize that we have to calculate those trigger settings before we start. So we end up gathering large sum of data set, which take like a whole forever in processing the data. Then the other challenge is also initialization. You have to have patience to ensure that the GPS signals and the system get initialized until the green icon is set before you proceed for data collection. And after data collection, before you put off the initial engine of the mobile device, the car itself, you have to back up the data so that you not lose that data. You have to back up the data, save, and ensure that the system using the tablet before you turn off your engine. Otherwise, you might end up losing the data set. Another challenge faced is during rain. If it is raining, the device is not waterproof. So you have to pack and find a tarpaulin to cover up the device. So that is the few challenges we experience while carrying out data collection in the field. Thank you for listening.
Yeah, thank you so much, Sylvester, for that. If you have any questions, we'll take questions after the whole session is complete. So if you have any questions, you can just hold your questions till then. We'll be taking your questions after that. So now we're going to move into the next topic, which is the potential application and then also the relationship between the grid tracking and the remote mapping. So, and Tokwe would be handling that. Tokwe, you can go ahead now.
Okay, everyone, can you confirm that you hear me?
Yes.
Okay, thank you very much to all those that have spoken earlier and to Sylvester for that very detailed explanation of operating device in the field, because that's the real nitty-gritty of the project. So as we've been hearing, the application of mobile mapping technology is actually very, very wide. So these are some of it. It's more or less like a way of not replacing, but substituting and complementing the work that people like land surveyors have always been doing in the past, and also contributing to things like utility in electricity, power sector, in telco sector, in road asset management and inventory, urban and regional mapping, planning, as well as projection of maps generally. Like I think Chukwudi did tell you that the Google Street View that you can all see on your mobile phone now, that gives you turn by turn location. If you are going somewhere, you can actually see how the building looks, you know, the bus stop you are going to stop. Was made possible by something like mobile mapping technology, which gives you geospatial information as well as backup panoramic imagery. So just in a brief, you can use this in grid infrastructure tracking. If you can use it in telecommunication for things like fiber optics, laying, and also inventory generally. Because by the time you drive through your infrastructure route or wherever they are, you can see the status and its timestamp as well. Another beautiful part of what geospatial technology and GIS does is that it just doesn't record space, which is location. It also has a time factor. So it's a spatial temporal kind of application. So it means that if you have an infrastructure, either electricity infrastructure or telco infrastructure, and you want to do quarterly maintenance reports, you can tell your crew to drive end of March, which is end of first quarter. They go again end of June. Then by the time you can do comparison and see either degradation, incursion, and different kind of things. So these are the applications. I can't say everything here. You can also go back and read more about it. So these are some of the applications of this technology. Omo, can you move to the next slide? So okay, now to what we now do with this in Nigerian Energy Support Programme, which is an electricity and power sector kind of program. We mostly use this device to understand the grid infrastructure. By the grid infrastructure, I mean things like pole, table, transformers, and all those kind of components of the power grid. Why do we do this? In many cases, currently in Nigeria and Sub-Saharan Africa, there aren't any available database or maps of the existing infrastructure, because when they were built decades ago, this kind of technology was not available. And we also don't have the culture of really keeping documents and maintenance. That's why they'll say maintenance are a problem in Africa. So what we are now doing first is to, first of all, document the entire grid, where we can find them, where they are, their characteristics, their categories. So you can see pole, the pole, you can assign the pole, either is a wooden pole, is a concrete pole, or is a metallic pole. The cable, you can look at the cable, the type, the voltage category, the transformer, and all those kind of things. So that is the main thing that we are using this mobile mapping to do, which is to map the existing grid infrastructure and their location and document them in maps, whereby it will be like you open your Google map, but you can see the map of the electricity grid where they are. So that's what we are doing. And it also then helps public distribution company and other operator of the grid in their asset management. Like I've said, if you drive around the town and you see all your wooden poles that are bent or damaged or they are tilting, you know the exact location of the pole. You know the count of those number of poles. So if you want to even prepare like a order to buy a new pole, it's easy for you to just open up this software and request for 15 pole. You know the street they are taking them to, you can plan your routes, you can plan the day the project will be done and all that. So that's where we hope this kind of technology will take our power sector too. Next slide, please. So another interesting part is all of you are here. Most of you probably are hearing about the mobile mapping for the first time. You came here to learn about remote mapping, which is mapping using heads-up mapping, which is mapping from your computer rather than going around, which our team, Emmanuel and other people that will speak after me are still going to show you. So how does this tie to the mobile mapping technology? Well, some of the way where this ties together is this. First of all, most of these remote locations that we are mapping today are selected based on their distances to the existing grid. So if we don't know where the existing grid is, we can't even isolate communities that need mapping for the purpose of maybe off-grid electrification or similar things. So one of the things is to properly offset and calculate distances of location and their proximity to the existing grid. So maybe probably some of the location we are going to map during this mapathon was selected because of their characteristics in the state where they are, and also due to their location relative to the existing grid. So that's one of the key relationship that exists between mapping the grid infrastructure and this remote mapping we do for settlements. So that's one thing. Also, if you go to a community, for instance, that the mobile mapper has already gone through, you can also estimate the number of connections, the number of users, and similar things that are possible in the community as well, and that also ties together. And obviously, anybody that is an engineer or knows about engineering practices will know that for front-end design and planning, the two kind of data that we collect during mobile mapping and remote mapping works together to give you a foundation to make very efficient and useful designs in order to plan electrification. Even if you take it probably out of power sector, there are also still similar applications. So I'm going to stop there, and if you have questions, you can ask us. And if you want to know more as well, we will give you materials and guides and directions where you can learn more about all of this. Thank you very much.
Thank you so much, Tope, for that. That was a very good session. So just so that we don't waste time, we can move to the Q&A session. So basically, we want to hear your opinion. You know, we've been talking about the mobile mapping technology. You've also seen how that can also come into play when it comes to gathering assets for electricity. So if you have any opinion or you have a question that you want to ask, you can just raise your hand. Then I'm going to call you, and then you can just give your feedback or ask your question. Hi, Ayotomi. Well, good afternoon.
Hi, good afternoon. Thank you for the presentation. Yeah, awesome. I wanted to ask, the second speaker was speaking about the challenges from driving and things like that, and I was wondering if perhaps maybe a way to go about it, and if the what's it called, the camera, I can't remember what it's called right now, is also, light enough for perhaps a drone to be able to pick up and then, fly around. Is that probably a better strategy, and is that something that has been used before? Thank you.
Yeah. Okay, Tope. Okay.
Thank you for the question. It's a good observation. There are drone applications for mobile mapping as well that are mounted on unmanned area vehicles. They call them UAVs. It could be a drone, it could be a plane as well. Those applications exist, but they are always more or less deployed in hard to reach and very hazardous or remote area, or for dangerous working conditions like the data set that we are mapping conventional grid that you see by the roadside, 11 kV, 33 kV. But if you want to map, the transmission line that goes at very high voltage, you might also deploy those kind of technology. So it's existing, and you can read more about them. It's different applications, so it's a very valid point. In places where we have substantial amounts of work that vehicle cannot go through, those are the kind of technology one would like to deploy.
Thank you for that. Sylvester, do you want to answer the question for the challenge on the field where you asked about the car? Ayotomiwa, can you come back with the first question you asked about the car?
Hello?
No, I think he already answered them. I mean, he already answered the question, actually. Yeah,
okay.
Thank you so much.
Okay. Yeah, thank you then.
I think we have another person raising his hand, Bob Boster.
Yeah, Bossa Robert. Hi, Robert.
Yes, hi. Thank you for this session. It's really good. I'm lucky to be joining in the second time. My question goes straight to how is, because I've seen really there's considerable work that has been done concerning the data that has been collected. So how can we be able to get this data and in which format? Basically, the reason is right now we are trying to do a research concerning climate and energy and application of AI, that's artificial intelligence, in energy. So, and we are required to apply AI in energy by use of data. So now something has come to my mind that, okay, with this data that has been available, is it really available or is not yet open to the public yet? And if it's not available, when will it be? And in which format specifically? So that at least if you know that, okay, it's available, then you can tell us all the requisite procedures for whoever wants to use it for research purposes. Thank you very much.
Thank you, Robert, for that. Tokpa, you can go ahead.
Okay, thank you very much for your very good question. The data is available. Most of the work that is being done by the Nigerian Energy Support Programme, not most, all of the work that is being done that is non-proprietary is going to be open source. By non-proprietary, I mean if we work with a private company, we cannot release their financial or anything that is proprietary to an individual. But under the basket of data collection that is driven from the Nigerian Support Programme, it is all the data is going to be available in format. For instance, if you go to our platform that was shared initially by Philip, we have the platform called Nigeria SE4ALL. We also have the content management system that is supporting that front end called data. I'll put the link there. If you go to the data.nigeria se4all.gov.ng, you are going to find any data we have in the normal geospatial format. You have it in CSV, you are going to have it in shapefile, you're going to have it in Google Kio markup language, KML, and all that is available there. But if you are a specialist in maybe computer vision and AI, of course, I have hope that some very smart people in the future might use some of these panoramic image for artificial learning and machine learning to extract more. That data set is also available, but it's not, it's a lot of data, like we said, is in terabytes, or maybe soon it's going to be petabytes. So there might be special arrangement to hand that over to research scientists to do machine learning and AI applications on them. But for the others, easy to upload and easy to undo data, all that is available and open source for everybody to use.
Okay, yeah, thank you for that, Tokbe. Okay, so now I think I go to Eke Malachi. Hi, Eke. Hello, Eke. I hope I got the name right. Eke, are you there? Okay, Joseph Ebin, you can go ahead with your question.
Hello, thank you very much. My question, although I had open source, my question was related to open source. So I'm more like asking, all data collected, open source, that's one. and 2 is in the area of incentivizing contributors. Is there a mechanism for incentivizing contributors that take part in this project? So I don't know where to classify it first, if it's one open source, and 2, if as a contributor, is there a mechanism to incentivize them? Thank you.
Okay, I'm going to ask your question back to you so that I'm clear. So in terms of open source, yes, every data set collected on this project has been collected. This project has been going on since 2018 in one form or the other, are all open source and are published under open source licenses. You can visit our website again to reconfirm this, and that will remain so. Then in terms of incentivizing collection, is it by participating in this Mapathon, or if you have your own data set that you want to contribute to this database? Can you clarify that?
Although part of this training is part of this workshop is for learners to at least learn more and see how they can be useful, in either in their spare time or what have you. All right.
Yes.
So in the incentivizing, because once we gather these skills or knowledge, because I think I've joined this at 2019. I've known NESP. Due to the hackathon I applied, that was at Lagos. They came around and also gave their pitch. That's 2019 when I know this program. So the knowledge gathered here can be used elsewhere. So like, is there any way or means, or is there any other program elsewhere that incentivize contributors? Like when you do this mapathon, maybe remotely. Yeah, basically remotely. Yeah.
It's a mechanism we are looking into, although I must also hint that the platform where we are mapping this on already has it's a voluntary and free and open. So whatever data you put on OpenStreetMap is to like the greater good. Is like contributing to Wikipedia's article. You don't really get paid for it. But in terms of incentivizing, maybe like a real, I'm talking about the data now, but in terms of incentivizing the effort to get data, yes, there are some mechanisms that we are working on that we feel we've not concluded on the final modalities, but we do know that there are, if we can incentivize data collection, which is the effort, not really the data now, because the data mostly is going to be open source, but the effort to get the data might not be free and open source because it will take resources. So, but we'll get back, we'll just keep a high heart for us. We'll get some information for us in the coming future. And also one thing I'll have to add is that on the platform, the content management system, we also promote crowdsourcing, which is like what you are saying, which means if you have any data set, you can upload it free. That's why I say we cannot incentivize data, but we can incentivize the effort. If you have free data, you can contribute out of goodwill and to the greater good of humanity.
Yes. Sorry, one more thing. Yeah, thank you very much for your response. And I'm coming from a Web3 background, so that's why incentivizing user is very important and paramount to me. So and I also appreciate the fact that you guys are also looking at this in the future, and if this is implemented, I would suggest on the blockchain will still be something to consider. That's just my own contribution based on this incentivizing mechanism. Thank you.
Yeah, we will look at the modalities. Blockchain is something that we've experimented, and the East Lagos was a similar initiative about using blockchain for renewables and all that. So thank you for your contribution. We are thinking of, it's not a very straightforward thing to find the incentivization mechanism that is easy to operate, but it's something that is necessary. Thank you.
Yeah, thank you so much, Joseph, for the contribution. Thank you so much, Tope, for the feedback you've given.